In today's video, we're going to cover over static electricity, semi and superconductors, and grounding. So in this part 3 video, what are we going to learn about? So we're first going to learn about static electricity. Second, we're going to learn about semiconductors. Third, we're going to learn about superconductors. Fourth, we're going to learn about neutralizing unbalanced charges. And finally, fifth, we're going to go over what grounding is. So let's get started. So first, let's cover over what static electricity is. So we already have discussed this in our previous video. So in our part video, we already talked about static electricity and dynamic electricity. So feel free to watch that video out to get a better understanding of what static electricity is. So basically, it is the imbalance of electric charge on a surface of a material. So in many cases, charges are produced by rubbing or touching. So as we can see in this figure here, this person is rubbing his feet against the carpet. So as soon as you shuffle your feet against the carpet, the electrons from your body shifts over to the carpet and it just stays there. So that's static electricity because the electrons are not moving anywhere and they're just staying there. And that also makes you positively charged. So that's why there's the imbalance of electrons. And then the quantity of electric charge is also expressed in coulombs, which is known as just C. And then one coulomb is equal to 6.24 times 10 to the power of 18 electrons or protons per second. So that's just a little bit of what static electricity is. And furthermore, in static electricity, we know that our body is a perfect conductor. So carpets are often made out of a material with properties of insulators. So when you rub your feet against the carpet, the electrons from your body transfer to the carpet and stay there. So as we just said in the previous slide, as soon as you shuffle your feet against the carpet, all the electrons from your body will just go onto the carpet and just stay there since they are perfect insulators. And now, since you rubbed your electrons, since the electrons from your body is now on the carpet, your body is now positively charged. So now, furthermore to static electricity, now let's say that you got up and you started going over to your door. So doorknobs are often made out of metal and they are really good conductors. So since you are positively charged now, because you shuffled your feet against the carpet and now the electrons are on the carpet, so since you're positively charged, electrons from the doorknob will transfer to your body to restore the imbalance of charges. So what happens now is since that you are positively charged now, as soon as you go to the doorknob to try opening it, since it's a metal and it's a perfect conductor, it's going to have electrons. And what's going to happen is that the electrons from the doorknob will shuffle over to your body, and that's also why you're going to feel a sudden electric shock. So that's just because of the imbalanced charges, and it's trying to just neutralize you and the doorknob. And now let's cover over what semiconductors are. So semiconductors are materials with higher conductivity than insulators, but with lower conductivity than metals. So you can say that semiconductors are in between normal conductors and insulators. And their conductivity is often increased by implanting foreign atoms into otherwise pure materials. So some examples are silicon, carbon, salty water, and humid air. So that's just a little bit of what semiconductors are. And now let's cover over what superconductors are. So superconductors are materials that offer little, if any, resistance to the flow of charges. And certain materials become superconductors when they're extremely cold, and that's about negative 137.15 to negative 273.15 degrees Celsius. So superconductors are usually made out of lead, mercury, metal alloys, and ceramics. And some examples of superconductors are nobanium, titanium, and germanium and nobanium. So these are just two examples of superconductors, and that's basically what superconductors are. So now let's cover over what neutralizing unbalanced charges are. So we're going to take the same example of the doorknob and the person that's positively charged. So an electric discharge occurs as accumulated charges on a material is neutralized and becomes balanced. An electric discharge can be harmless or incredibly dangerous because they can shock people, damage electronic equipment, and even cause fires and explosions. Going back to this example, so positively charged body can get neutralized by touching the doorknob. So since you're positively charged and this negatively charged, as soon as you touch it, it's going to try neutralizing the unbalanced charges. So then it's going to be equal on both sides, and that's also why you feel the sudden electric shock. So that's what neutralizing unbalanced charges is. And now let's talk about neutralizing unbalanced charges by grounding. So connecting an object to Earth with a conducting wire is called grounding. And grounding an object is an easy way to neutralize conductive materials. So since Earth is so large, it can easily supply enough electrons to neutralize a positively charged object. So for example, here's just the Earth, and we're going to take the example of the Eiffel Tower. And that's basically it for this video. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our part 3 video.